Today we'll study about global atmospheric circulation. First we'll see what are the important parallel latitudes that are present within the Earth. This is 0 degree latitude, what is called equator. This is North Pole, so at 90 degree latitude. From equator towards north and south, the latitude are divided in the same way. The 23.5 degree north latitude, it is called the Tropic of Cancer. Then towards south, 23.5 degree, it is called as Tropic of Capricorn. Then at 66.5 degree towards north, it is called Arctic Circle, and 63.5 degree south, it is called as Antarctic Circle. Then at 90 degree north, it is called North Pole, 90 degree south, it is called South Pole. So these are the parallel latitude. Then comes to another effect that is called Coriolis effect, which will give the direction of different wind belts. So it is important. So what is Coriolis effect? This is occur because of the differential velocity of Earth. So if you see, the equatorial part has greater perimeter than the polar part. So, but the in equatorial part, the Earth has to cover more distance than the polar part, because this thing radius, it gradually decreases towards the pole. So that means this part and this part. So in this part, Earth has to cover lesser distance than this part. So, but they all will cover in one day. So that's why the equatorial part, as it has to cover more distance, so it will have a greater speed than the polar part. So the speed of rotation of Earth, that decreases from from equator to pole. So that means it is 1600 km per hour at equator and almost you can say 0 degree at pole. So because of this differential velocity, the Coriolis effect occurs. So what is the Coriolis effect? If an object is thrown from north to south, then it will deflect perpendicular to the Earth's rotating direction. So it will be the rotating direction from west to east. So it will deflect towards right or left depending upon the hemisphere. So if we are on the northern hemisphere, then because of Coriolis force, if you throw an object into the air, then it will deflect towards the right side. So if you are facing towards north, it will deflect towards the right. If you face towards south, so this side will be your right side, so it will also deflect towards the right side. So it will depend upon the viewer's perspective. So it will always deflect towards the right of the viewer. So if you are standing here, then this side will be your right side. If you are standing and facing towards north, this side will be your right side. And if you are standing here and facing towards south, so this side will be your right side. So if you are in northern hemisphere, then it will always deflect towards the right side. Then in the southern hemisphere, it always deflects towards the left side of the viewer. So this is your Coriolis effect. Sometimes it is called as your Coriolis force, but it is actually Coriolis effect. It is not a force. So the Coriolis effect that causes a moving object on the Earth to follow a core path. Moving object means it is showing a moving object on the air. So the northern hemisphere, it will follow a right path, or it will deflect towards the right of the viewer. Then in southern hemisphere, it will deflect towards the left. The Coriolis effect, it is because of differential velocity of the Earth's surface. So the amount of effect, you can say, it increases from equator to pole. The Coriolis effect, you can see it is 0 at equator. There is no effect of Coriolis force at the equator, and it is maximum at pole. That means Coriolis effect that increases from equator to pole. You can see this equator part, it is moving at 600 km per hour. Then gradually the velocity decreases towards the pole. So as the velocity decreases, the effect will intensify. So there will be more Coriolis effect when the velocity is less. So Coriolis force that occurs because of differential moment of ground, you can say. If one part of the earth is moving faster at faster rate than the other part. So that's why this thing is happening, or the effect is happening. And it will affect the direction of wind, or it will help in a different global circulation pattern. So how it will affect, that we'll see in the later section. So you can take the example to understand better. You can take the example of that merry-go experiment. It is available in YouTube. You can see the path of the missile. If you are targeting to this uh, area, then you have to throw the missile in different directions so that it will reflect to that direction. So you have to calculate the Coriolis force. These are the cause, but we've already explained due to different velocity. Due to different velocity, the effect will intensify when the velocity will decrease. So it is 0 at equator and maximum at pole. It comes to the pressure belts of Earth. In the previous class, we have discussed about that Earth's heat budget. In that section, we have discussed the differential heating of Earth. So different part of the Earth, they doesn't receive same amount of heat, or doesn't have same amount of insulation. The polar part, where the ray are slant, you can say, or they approach the pole at an angle. So in that part, the insulation is lesser. But the equator, if the ray hit the equator directly, so that it has greater insulation. So that is a differential heat condition. So the polar part has greater heat, sorry, equatorial part has greater heat and polar part has lesser heat. So that will produce a differential heating condition where this part will have high heat, this part is have low heat. So that will produce a pressure belt. As you know, if the air will get hotter, then it will become lighter and will rise upward. So that will produce a low pressure condition. So because of this differential heating, different pressure belts are formed within the earth. What are the different pressure belts? First thing, equator, because equator is receiving more heat, so it will be a low pressure zone. This is the equator. Then around 30 degree north or south degree, north or south latitude, we have subtropical high pressure zone, what we call horse latitude. This is called horse latitude, which is a high pressure zone. Then we have another low pressure zone, that is subpolar low pressure zone. Then another high pressure zone, that is at polar region. So low pressure, then high pressure, then low pressure, then high pressure. This follow on both hemisphere, both northern hemisphere and southern hemisphere. Equatorial low pressure, it is at 0 degree. Subtropical high pressure, it is 30 to 35 degree. Then subpolar low pressure, it is 60 degree. Then polar high pressure belt, it is at 90 degree. Then comes to circulation cells. So this is important. As you know, the equatorial part, it is receiving much of the heat. So this part is a hotter region. So what will happen? The air will in this region get hotter and they will get lighter. They start to rise in the equatorial part. They will start to rise at certain height. When they will rise, they will become cooler. Then they will start to move horizontally on both sides, towards the north or towards the south. So after traveling horizontally on the upper atmosphere, they start to cool. They start to get denser. So at 30 degree latitude, that is your horse latitude, they will start to descend. So here cold air will descend. So this 30 degree latitude will become high pressure zone. And as air is getting hotter here, they will rise. So this will become low pressure region. Similar thing also happen in the southern latitude, the southern hemisphere. Air will descend here. So what will happen? At the equatorial part, because of the heat, air will get lighter. Then they will rise. They move horizontally on the upper atmosphere. So during the horizontal movement, they will become cooler and denser. So at 30 degree latitude, they will descend. So when they will descend, the 30 degree latitude will become high pressure zone. Then this will become high pressure, this will become low pressure. So generally, wind always flows from high to low pressure. So that means from 30 degree latitude to wind flow towards the equator. But because of Coriolis effect, in northern hemisphere, it will deflect towards the right, and in southern hemisphere, it will deflect towards the left. That means wind actually flow like this. Instead of flowing from the north, it will flow from the northeast side in the northern hemisphere, and it will flow from the southeast in the southern hemisphere. So these are called as trade wind. These are called as trade wind, northeast trade wind and southeast trade wind. So again they will come to the equator. So at equator, then again they will got heat. They will get heat from the equator. Again they will become lighter. They again will rise, and they will produce a convection cell type of thing here. That is called as your Hadley cell. These are called as circulation cell. These are forming in the upper atmospheric layer, where wind goes from low pressure region to high pressure region, and the surface, it is from high pressure region to low pressure region. So when from, you can say the southeast trade wind and northeast trade wind, they will converge at 0 degree latitude, or we can say 0 to 5 degree latitude on both northern and southern hemisphere. So this region it is called as your intertropical convergence zone (ITC), or you can see it is also called as doldrums. Because when two air will converge here, there will be no wind here. There will be no wind. It is also called a zone of peace. Okay. So the cold air that is descending at the 30-degree latitude or horse latitude, it will diverge. It will move towards the equator and also move towards the polar region. This is subpolar high pressure zone. This is subpolar high pressure zone. Sorry, low pressure zone. This is polar high pressure zone. This is low. This is high. So now this is high. So these diverging wind they will move towards the low pressure zone. Now see this cell. This is actually not formed by thermal process or heating process, because first we see in Hartley cell, because of heating, air will rise here and then will descend here. Then at polar region, this is your high pressure, this is your low pressure region. So wind will flow superficially from, you can say, 90 degree to 60 degree. 90 degree to 60 degree, and reaching 60 degree, it will get hotter, then it will rise upward. Then on the upper atmospheric part, it will move horizontally and then again descend at the pole. So a circulation cell will create here because of differential heating, that is called as a polar cell. That means the Hartley cell and polar cell, those are two produced by thermal condition or temperature condition. In Ferrel cell, it is the effect of polar cell and Hartley cell. It is called as a mechanical cell. It is called as a mechanical cell. So how this forms? Now see. So the air that descend here, it will move towards both sides, because they will diverge here. So this diverging air, obviously, they will move towards the this is high pressure zone, this is low pressure zone. So it will move towards the low pressure zone, obviously, in the superficial part. So when it is moving towards from 30 to 60, as you know, from equator, if you go towards the pole, the Coriolis effect will increase. So at this position, the Coriolis effect will be more. Instead of flowing towards, you can say, towards northeast, they will flow towards the west. The deflection will be more. So that's why they will flow towards the west. So that is called as your westerlies. This is called as your westerlies. Because Coriolis effect will be more here, so they will move towards the west. So this is high pressure zone. When they will moving on the surface, they will get hotter at 60 degree latitude. Then again they will rise upward. So when they will rise upward, they will move towards some move towards the pole, some move towards the equator. So then again, that part is moving towards the equator. It will descend at 30 degree latitude. It will descend at 30 degree latitude. Here, and again it will move towards this region, towards this region. So that's what the Ferrel cell will produce, like this. So in a simpler way, you can explain like this: air will got hotter here, it will rise upward, it will move towards both the latitude. Then around 30-degree latitude, they will descend. They will descend. They will diverge here. So this part will become northeast trade wind, and this part become western lights. When it will reach 60-degree latitude, then it will become hotter again. Then again it will rise and move both towards pole, towards equator. So towards it is moving towards the pole. Then at 90-degree latitude, it will become colder and denser. It will descend. Then again it will come back to 60-degree latitude as eastern lights. Because if it is moving from this 90 degree to 60 degree, it will deflect towards the east. That's how three sails will form on both the hemisphere, named as Hartley sail, Ferrel sail, polar sail. And the wind belts are, you can see, these are the wind belts. This is northeast trade wind, this is south east trade wind. Then this is western lights. Western lights is because correlation effect will be more. So during from wind flowing from 30 to 60 degree, it will deflect towards the west because of correlation effect. And this is a polar eastern lights, that is from 90 degree to 60 degree, and it is also because of correlation effect. It will deflect towards the eastern part. So these are the different wind belts and circulation set. Northeast trade wind, southeast trade wind, then western lights, eastern lights. Comes to boundary at the equator, you can say, where northeast and southeast trade wind meet. That is called as doldrums or intertropical convergence zone. And the boundary between the trade wind and the prevailing western lights, that is horse latitude, 30 degree, and the boundary between the prevailing western lights and polar eastern lights, it is polar front. That means this is your intertropical convergence zones, or you can say doldrums. This is your horse latitude, and this is your polar front, where polar eastern lights and western lights meet. That is polar front. This is polar front. This is intertropical convergence zone, and this is horse latitude. So where two wind they will meet, there will be no wind. There will be zone of peace, you can say. There will be no wind flow in that region. And in most of the cases, you'll find all the desert region at you can say mid latitude region, because at mid latitude region, that is 30 to 35 degree, that is where cold air descend. So where cold air descend, there will be no cloud or there will be no rain. So that why you will find more desert in mid latitude region or in along more horse latitude region. Let's come to tropical cyclone. So these are cyclone. These are characterized by strong wind and rain. So it is produced because of low pressure condition, and mostly the tropical cyclone always form on the oceanic region. So it has a different name. It is in South America it is called as hurricanes. In North Pacific it is called as typhoons, and Indian Ocean it is simply called as cyclones, and in Australian it is called as willy willies. All are same, only at different region it is named differently. So it is produced in tropics region, in between you can say 0 to 30 degree latitude on both sides, northern and southern hemisphere. So it is formed during the late summer condition or early fall condition, where the temperature is maximum. So obviously, as it is produced because of low pressure, it require a certain temperature condition. Mostly, it is produced when the sea surface temperature increases above 26.5 degree, or sometimes it's to 25 degree. So when sea surface has greater than temperature 26.5 degree. So what is tropical cyclone? How it is formed? We will discuss. First thing, suppose a portion of ocean, it will get hotter. Okay, where it will the temperature is greater than 26.5. Portion of oceanic ice. Another part also ocean. This part is getting this part is more hotter. So if it is hotter, then what will happen? Air will rise upward. Air will simple rise upward. So when air will rise upward, then it will produce a low pressure condition here. Produce a low pressure condition. So if it is a low pressure condition is created here, then from the nearby region, wind will flow to this low pressure region. Because wind always flow from high pressure to low pressure. If a low pressure will create it, then wind will automatically flow towards the low pressure region. So now it depends upon whether it is in northern hemisphere or whether it is in southern hemisphere. If it is in northern hemisphere, then a cyclone will produce in an anti-clockwise direction. How I will show you. So now the air will rise, and colder air will try to fill the low pressure zone. Then again, these colder air, when they will come in this region, they will also become hotter. They start to rise it. So when air will rise upward, so it will contain moistures. So at this region, the rising air, they will contain latent heat of vaporization. The latent heat of vaporization, because heat should be added some in a liquid to become gas. So during formation of vapor, latent is added. So that means the rising air contain much more amount of heat. So when it will reach to the upper atmospheric surface, so it will rise approximately, you can say 12 kilometer or 12 to 15 kilometer. They start to cool, and they start to condense. When they will start to condense, they will release all the heat here on the upper atmospheric surface, and that will also become a low pressure region. So wind rising from the ocean surface containing moisture and latent heat, and it will condense at the upper atmospheric surface and produce a low pressure here. Then in northern hemisphere, if you see, the wind is flowing towards the low pressure region, they will deflect towards the right side. They will deflect towards the right side like this. They will deflect towards the right side, and because of this deflection, they will start to rotate here in a anti-clockwise direction. They will start to rotate in an anti-clockwise direction, and same thing also happen on the upper part. They start to rotate in an anti-clockwise direction. So first thing, this ocean surface will become warmer, then air will rise upward. To fill this void, air from the nearby region, or you can say surface wind, come to this region, and the surface wind that will try to fill the low pressure region, they will also become hotter, and they will also become rise. They will also rise, and the process will continue like this. and gradually they will start to rotate and produce a cyclone. So if it is in northern hemisphere, it will rotate in the anti-clockwise direction. If it is in southern hemisphere, it will rotate in clockwise direction. You can see here. So because of the latent heat of condensation, that will release all the heat and produce a low pressure on the upper atmosphere. So that's how a cyclone is formed. So depend upon the speed, it's classified into three types. If the wind is less than 61 km, it is called as a tropical depression. If the wind is in between 61 to 120 km, it is called as a tropical storm. And if the wind exceeded 120 km per hour, then it is called as a tropical cyclone. So for a cyclone, wind speed must exceed greater than 120 km. So say this is our 0 degree latitude. So tropical cyclone that forms in between 0 to 30 degrees on both sides. After formation, it will start to move with the wind. Suppose it is forming here, then it will start to move along with the wind. So when it will moving over the ocean, it will collect the moisture. It will collect the moisture from the ocean water. So it will start to intensify. And as it approaches towards the land region, then when it will enter to the land, the moisture supply it will cut off, because in land region it will not get that much of moisture. If it will not get moisture, then there will be no latent heat of evaporation, or there will be no heat. So that's why we can say the cyclone that weakens when it will approach to the land, or what we'll say landfall. When it will enter to the land region, it will start to weaken. So that is called as a landfall. So the simple reason is the moisture content or moisture supply that will be cut off in the land region, which it will getting in the ocean region. This is the structure of a cyclone, you can say. So the center of the cyclone, it is called as the eye, where the wind speed is 0. There is no wind, it is a calm region. And this is called as your eye wall. So from outside of the cyclone towards the wall, the intensity of the wind and rain increases. And the eye, they are very calm. And each cloud, these are cloud, they are separated by rain band. They are separated by rain band. You can see here also. These are eye wall, these are rain band, these are cloud. And at eye, it is a calm region. So it contains large number of thunderstorm arranged in a pinwheel pattern and with band of thick clouds. Then the wind speed and the intensity of the precipitation both increases towards the center of the system. It reach maximum at the eye wall. Maximum at the eye wall. At the eye, actually, there is no wind. It is a very calm zone, and you can say the thickness of the eye also determines the intensity. If the eye is very small, generally a shrinking eye, that indicates an intensifying hurricane or cyclone. So eyes is about 40 km in diameter, or some ranging from 20 to 50 km. In between 20 to 50 km, it is the diameter of the eye. So this is the structure of a cyclone. This is the landfall condition we already discussed. After landfall, there is huge rainfall occurs because still the cloud contains much more amount of water. So after landfall, the moisture content, that moisture supply, that cut off and it become weaker. So this is your tropical cyclone. So tropical cyclone, there is a scale that is called as Saffir-Simpson scale, which indicates which categorizes the cyclone on the basis of its intensity. So the category 1 wind speed is 122, 153, category 2 154 to 177, then 3 178 to 209, then 2010 to 249, category 4 5 is greater than 250. So these are damage parameter. So it is used for cyclone and hurricane. Generally used for tropical cyclone. So this is all about your tropical cyclone. So it is formed because of low pressure condition. First thing, low pressure. Second thing, latent heat. Third thing, Coriolis effect. Those are the important factors for the formation of a tropical cyclone. You can say this is your condition. More than 25 or 26 degree, you can say. Then Coriolis effect. And also the tropical cyclone, but cyclone doesn't occur on the equator because there is no Coriolis effect on the equator. Because of lack of Coriolis effect, wind cannot move in a circular path. So, but in the tropical region, they start to deflect. But in equator, the wind doesn't deflect. So without deflection, they cannot produce a circular path. This is the northern hemisphere condition. It will produce anti-clockwise cyclone, and southern hemisphere it will produce a clockwise cyclone.